This 4-inch vise has served me very well for almost a decade, but on a machine this size, it eats up a lot of Y travel and it limits the size of workpiece that we can hold. So today we're going to replace it with a fixture plate. Stick around. Welcome back to Cloud 42. I'm James. When I got my first milling machine, the very first question I asked was, what size of vise should I buy for it? And for my Grizzly, which is about the same size as this PM728 mill, I opted for a 4-inch vise, and I bought this one from Shars, and this has served me well for probably 10 years, and it's still going strong. I moved it onto this machine after I built it, but any kind of vise on a machine this size is going to have some serious drawbacks. Let me show you what I mean. Here's a workpiece that is for an upcoming project that I want to process on this mill, and it will fit in this vise. This is hot rolled steel, and this is 6 inches wide. So I can clamp that down, and that will fit in the vise on this machine. And this machine does have more than 6 inches of travel, so it shouldn't have any problem processing it. Let me bring the Z down here. Should get it close. So I've got a tool in here, and you can see I can get behind the workpiece easily enough. In fact, if I bring this forward, I can get way behind the workpiece. I've got plenty of space there. But if I take this and go the other direction, you can see that the vise jaw comes up against the column, and that is as far as I can go, and this tool is not out to the front of the workpiece yet. In fact, that tool would come down and only come down right here about 3/8 of an inch behind the front of the workpiece. I actually can't get around the front of it. Now I would be able to get around the front of this if I could shift the vise back, but that wouldn't do me any good because my limitation is that the fixed jaw of the vise is already hitting the column. So pretty much no matter what I do, I can't get this back further. Now there are some things that I could do, like I could flip this jaw around. This jaw could go on the back side of the vise, which would allow me to slide the workpiece back further, which would allow me to reach around the front. But then I'm going to start to have problems on the other end. I come all the way out here, and to get this tool around the outside of the workpiece, it doesn't quite make it all the way to the back of the jaw. So I have like this much space back here that's unusable with the vise in this position, and I can't actually get to the back of the workpiece if I put the jaw on the back either. So what I really need to do is be able to move this workpiece back so that the back edge is close to the back of the table, because I can easily get around the back of the mill table. That's how this thing is designed. I just can't get around the back of a 4-inch vise. Now there are some other options. I could take this vise and I could turn it sideways. Now I would no longer be able to clamp it down in the T-slots because this is has affordances on it for going this direction, and if I rotate it around and then I've got the crank handle on here, that's going to hit the table. So I'm going to have to, go one step at a time, 2 or 3 flats at a time. So with the vise, we really have a problem with a workpiece this big, and it's not that the mill doesn't have the travels. Let's see, the actual travels on this thing are even with the vise on there, we've got 195 millimeters, so that's almost 8 inches. This is a 6-inch workpiece. We should have no trouble getting around it, but just because of the limitations of the vise, we can't. So what we really need is a way to mount stuff more flexibly on the table so that it doesn't go off the back. Now I could use toe clamps and I could clamp this down right in the T-slots, but then I don't have the ability to grab it by the bottom edge and go all the way around the workpiece in one setup because I'll have clamps on it. So what's the solution? The solution is a fixture plate. This is an aluminum fixture plate from Saunders Machine Works. So what this is a slab about, if I can get my fingers on it, about 1 inch thick of 6061 aluminum with a grid of 1/2-inch threaded holes in it. And these are not just simple threaded holes, they are threaded, but the top portion of the hole is actually counterbored, and that's a precision diameter that you can use gauge pins or dowel pins in for fixture alignment. So this is a 1/2-inch dowel pin, which is 2 or 3/10 oversize, and these bores are 1/2 thou oversize, 5/10 plus or minus 2 is the spec. So they're a very, very close fit on a standard size dowel pin. and that allows you to line things up, use these as stops. And you can also use whatever other kind of hardware you want to mount things down to the fixture plate, and you have a lot more flexibility than you would with T-slots or than you would with a vise. Now, I actually paid for this. I placed an order, paid cash for this fixture plate for this project. This one is made specifically for the PM728 mill. And then as soon as I placed my order, John Saunders reached out to me and asked me if he could send me one of his new mod vises. Now, I actually have the Gen 2 mod vises that I was planning on using, but he's got the Generation 3 ones now, and he sent me one to try. Now, the way the mod vise works is this is a two-part vise system, and unlike a two-part vise system that you would clamp into the T-slots, this actually indexes into the plate, so it's much easier to immobilize it so it doesn't slide around. So the fixed side has a set of index pins that index into the counter bores so that it can't move, and then the moving side has slots so that you can position it where you need it. And then it has a cam action, these clamping bolts that go through the moving jaw are in a slotted hole so that you can preload it back, and then when you clamp down on this with the flat head fastener, it actually squeezes that jaw in toward the workpiece. So if I grab this same workpiece and set it in here, I can move this around, preload that against the workpiece, tighten all the fasteners down in the fixture plate, and then use these two screws to actually clamp it and hold this in place. And this allows me to get all the way around it, and I can put these anywhere I need them, so I can actually get it positioned all the way back to the back of the fixture plate, which is parallel to and coincident with the back of the table. And I can move these around as much as I want. And you can put them at any angle. They don't have to be sideways. You can put them front to back. And since all the fasteners to tighten these are on the top, you don't have any issues like you do with a regular vise where you got a big crank handle coming out of one end of it. Now, this particular vise has these smooth clamping bars in it, but he also sent me a set of his jaws. These are analogous to Talon grips, which I made in a previous video many, many years ago, but these are specifically sized with fasteners to fit the Gen 3 mod vises. One little note, the Gen 3 mod vises use metric fasteners and the Gen 2 use imperial. So that's kind of the main difference. There are some other minor differences, but they don't really matter for this application. Now, when I bought the fixture plate, I also bought it in the kit that comes with the T-slot hardware to fasten it to the mill and some packages of these rubber plugs. And these just go in all of the holes to plug up the holes that you're not using so that debris doesn't get down into the holes and onto the table. And it just keeps them cleared out so that you can pop them out when you need to move fixtures around and they're not always full of junk. You know, it's actually pretty painful taking a vise off of a mill like this. I spent a lot of time tramming this in, and I don't want to take it off. There's just something in my brain that says anything that affects the head tram or the vise tram, I don't want to do it because I don't want to tram it again. Now, I actually 3D printed these TPU fillers for the slots in the table just so that I wouldn't have to clean junk out of them, but we will not need those now. Now, one thing that we are going to need is we're going to need to put this Toolsetter back on. So we will need to make provisions to mount that on the fixture plate. By the way, don't drop one of these. This is a breakaway shaft just to, so it'll snap off and you can replace it if you ever get in any kind of collision with the Toolsetter. And it turns out it'll snap off if you drop the Toolsetter on the floor too. So don't do that. Maybe I should just put it on the floor. We'll see if that ends up being foreshadowing. I looked at a whole bunch of different ways to actually mount the Toolsetter on here, and I was going to do a 3D printed base plate, and then I was thinking about CNC machining a base plate, and I decided the easiest thing was going to be just to drill and tap a couple of holes in the fixture plate itself for the mounting screws. So I actually brought in the model. Saunders Machine Works provides a model of the fixture plate, and I just brought that into CAD and figured out exactly where on here I needed to mount the Toolsetter, figured out where the holes needed to be, and made myself a drawing. So we just need to set up the fixture plate here in the milling machine so that we can drill and tap some holes. And I think these vices will open just far enough to make that happen. And make sure I understand where I need to zero this thing. And it is around this hole right here. I'm just using my touch DRO with a probe here to find the center of this hole. Then we'll chamfer these a little bit. I'm actually using a form tap here, so this isn't, it doesn't actually cut, it actually just rolls the threads into the aluminum. So you use a slightly larger drill than in this case it was a number 25 for an 832 hole. And then this is a roll tap or a form tap, which will just form the threads, and it shouldn't pull any swarf up or push any swarf down. This is a through hole, so I could have used a spiral point tap, but in aluminum, you get stronger threads with a roll tap. And in fact, that's how these are actually tapped by Saunders Machine Works at the factory. 832 screw fits. It better. Now, before I actually mount the fixture plate on here, I want to make sure the table is absolutely clean and absolutely free of burrs. I can actually feel a little spot here that's raised slightly, probably from dropping a tool on it. So I'm going to use these flat ground stones and just feel around the table like I can feel that. You can hear it. Those little nicks, and just take those off. Chances are they'd actually kind of disappear into the aluminum when I mount the stone, or mount the plate. But we're better off removing them. Now the other thing I want to do, since this is cast iron and the plate that I'm going to put on here is aluminum, we're going to have dissimilar metals, so I want to put down something to try to prevent rust. Saunders recommends the LPS 3. I didn't have any because I live in a climate where there's normally not much rust, and so I bought a can and we'll just put some of this on the table. Now I'm just using a small section of the paper towel, so I'm not taking it all off, I'm just spreading it around. I'm getting a nice thin film. Now I'm going to use a little bit of copper anti-seize on all the fasteners. Is this really needed? Probably not on these ones, but it's not going to hurt anything. Okay, now let's tram it in, and I'm being really ambitious. This is a 1/10 indicator. Let's just see if that ended up being a bad idea. Okay, that looks pretty good. I'm going to snug these all down a little bit. So that's 2/10, and we're just on this front edge. So let me go get a straight edge, and let's set it up on the actual pins here and tram it in according to the actual hole pattern. Okay, this is a Starrett Precision straight edge, and I'm just going to set it here, and we'll set it up so that it's bearing against a couple of pins. They're very close fit. Then we'll push the straight edge back against it, and I'll go grab a couple of little clamps and we'll clamp that in position. You've probably seen these clamps before. I used them in a previous video. These are 3D printed. I use them for clamping down glass on the Avid router, so they should be suitably gentle for this. That's a couple tenths end to end. Let me snug and see if we can replicate it. Yep, that is easily within 1/10,000th of an inch end to end, measured off of the pins. And then the last step is going to be to torque these down. That seems heavy. Let me see what it actually says. It says 60 foot-pounds, but this is a 3/16 inch hex. There's no way. Well, that's not even close to 60 foot-pounds. I don't know if I'm reading something wrong or not, but those seem plenty tight. Okay, I was really super confused, so I turned the camera off and I went and read some websites and played around with this a little bit. And I now have it all torqued down, and we are within probably 1/10,000th of an inch, if that. Maybe not even that. Now, I did misread this. I thought this was 1/2 inch hardware, but these are actually the 3/8 inch, and so this is supposed to be like 21 foot-pounds. And it turns out 21 foot-pounds is a whole lot less than 60 foot-pounds. So these torque down very easily. Who knew? 21 does not equal 60. Last step here is to mount the tool setter. That's going to go right there, and I should go ahead and put the plugs in that are going to be underneath it. Apparently there's some talent required to insert these. And now, hopefully, the holes that I drilled and tapped will line up. And then, of course, the last step is going to be to locate this properly so that the machine knows where it is, since I'm sure we moved it slightly. Looks good. Now, before we go any further with this thing, I do want to actually try to set something up, but before we do that, I am going to throw a marker, a Sharpie, into the spindle, and let's mark out the actual reachable work envelope on the plate. I don't know if this is a good idea or not, but I can't think of a reason why it wouldn't be. Oh, and I can actually go back a little bit further. Because I don't have the vise sticking out the back, we can go back another, let's call it 12 millimeters. Let me change the settings here. Let's try not to actually break the tool setter here. Okay, that means that the spindle can reach all the way out to here. And I probably should come back and actually engrave this line in the plate, at least with a diamond drag engraver, just so that I can see where it is. And then we can use that as a guide for setting up workpieces and knowing that we can get all the way around them. So let's set up a workpiece. Needs to go right here. Now in this case, these mounting bolts are going directly into aluminum, so the anti-seize is pretty important here. Now there are a bunch of different fasteners here, and they all require a different amount of torque, and I discovered that you can buy inexpensive import torque wrenches on Amazon for less than $30 a piece. So I've got one that's set for the torque for the jaw fixture, for the jaw torque. I have one that's set for the clamping torque, and then I have one that's set for the mounting torque to the plate. And for these two, since they're the same, you can see I've got a marked clamp and mount, just 3D printed those right into the Gridfinity trays that these are going to live in. For this particular setup, I'm going to swap out the smooth bars, and I'm going to put in these cleats that will grab them. Okay, for the moving jaw here, there are pieces that are going to have to slide around, so we'll go ahead and put anti-seize on those, on the clamping surfaces here, on the screws, and on the surface between the jaw and the base. And this is all just, you know, this is all detailed in the instructions on the Saunders Machine Works website. I have no special knowledge. I've never done this before. I'm just doing what it said, and probably making a horrendous mess. So for clamping, these should go all the way down and then come back out 2 full turns. Okay, that's the setup, and now we can take our workpiece in and out if we had multiples. And in theory, tightening these down should clamp it. So that's forcing this jaw in and causing those teeth to bite into the workpiece. And since they are biting in, I'll torque it a couple of times. And now that should be also within the work envelope. Let me bring the Sharpie down and let's find out. Yes, we can easily get off the back of the workpiece. And we can easily get way past the front. In fact, we've got all kinds of clearance in the front there. I got 1 inch, 25 millimeters. That is so much better. In fact, we could probably get around something even a little bit bigger than this. Not quite 8 inches, though we do have probably just a little bit more than 8 inches of travel now. Let me see what we've got. 207 millimeters, which is 8 inches 150. So that is going to work so much better. So for an actual workpiece, which this will become in a future video, we'll go all the way around and contour this to shape, and then we'll put the smooth jaws in and flip it over and grab it from the smooth sides upside down to finish the opposite side. I know, I told you the machine was done, and then I made yet another video putting even more stuff on it. I'm sorry, not sorry. I was actually going to make this video about making a part using this piece of stock until I discovered that I couldn't get the tool all the way around the perimeter. So we've got the fixture plate now. That video will be coming up because I have yet another project over there waiting for the part that I need to make out of this piece of stock. So that will be coming up soon. I did talk to Matt at Precision Matthews, and he would like to continue the discount code. So there is a discount code down in the video description for 5% off if you're interested in getting a mill like this. And I think there is just one more thing that I forgot to do. That ain't going anywhere. Thank you for watching.